Lesson 2, we're looking at dividing integers. Same rules as what we did with multiplying integers, good guy, bad guy. So if you look on page 52, a machine drill is being used to access water under the ground. If the machine drills the same distance each day, what is the change in the location of the bottom of the hole each day? So if you look at the picture, you can see the water is 160 feet below the ground level, and they did that evenly, the same amount each day over 4 days. So we could look at this as negative 160, since we're going down, negative 160 divided by 4. You can use your fact families, or we can just divide it out. It's probably what we would normally do. Negative divided by a positive is going to be a negative. This is like the bad guy comes to town is bad, so we know it's going to be negative, and then you can just divide out 160 by 4. And then just make sure you remember, though, that your answer is going to be negative. So divided out is 40, answer is negative 40, which means they went negative 40, or they went down 40 feet each day. So again, same rules as multiplication as we do these problems. If we look at the try it, suppose the machine drilled the same distance into the ground for 3 days. And they reached water at 84 feet below ground level. What was the change in location of the bottom of the hole each day? So this time it was 84 feet that they're going down, so negative 84. This time it's being split up over 3 days. And if we work this out, we know negative divided by positive is going to be a negative. And then if we divide 84 by 3, is 28. So answer would be negative 28. So over here, we could say that the each day location changed by negative 28 feet, or decreased by 28 feet. Looking at the number line that they have over on the side, if we were ever asked to do something with the number line, what we could do is just say that each day, if they go down 28, this would be negative 28 after the first day, and then if we add another negative 28, that'd be negative 56. Add another negative 28 would take us to negative 84. So that's kind of a way that we could check our answer to make sure that we did the problem correctly. Example 2, these are just some regular problems we're working out. So negative 27 divided by negative 3. Negative divided by negative, that's like the bad guy leaving town, so that's good. And we know 27 divided by 3 is 9, so that would be a positive 9. So if we look at the try it part A, once again we have a negative divided by negative is going to be a positive, and then 40 divided by 5 is 8. So final answer would be 8, or positive 8. Part B, 40 divided by negative 5, positive divided by a negative, that's the good guy leaving town. That is bad, so answer is going to be negative, and once again 40 divided by 5 is 8. So answer would be negative 8. A way we could do for checking these with fact families, multiplication and division work together. So if you got your answer, you could actually check by taking negative 8 times negative 5, and you should get 40 that you started with. And part C, anytime you take 0 divided by a number, you will get 0. And that problem, you might look at it as 0 is actually a neutral number. It's not positive or negative. So anytime you do that, your answer is just going to be 0. So if you would work a problem out, we're not going to put ever -0 on an answer. We just put 0 in that case. Example 3 asks if the following quotients are equivalent. So just a few different looks that you could potentially see as you do problems. We have a negative, and then in parentheses we have 18/4. Anytime you have a negative outside the parentheses, that negative sign just keeps moving along as we work the problem out. So 18 divided by 4 is 4.5, or I might put it as 4.5. And then the negative just keeps coming along. So whichever way you do that, I would probably do it this way and say that's -4.5. The second part here, -18 divided by 4, negative divided by positive is a negative. So that again would be -4.5. And then the last one, they've got a positive divided by negative, also would be negative, and also -4.5. So are they equivalent? We would say yes, and you could say they're equivalent to -4.5 or -4.5. Again, if we can keep things as fractions rather than decimals, it's going to be potentially easier for you guys as you do these problems. So if we look at the try, it says which of the following are equivalent to -5, and we'll just number these so we can keep track easier about which we are selecting, and it's possible that more than one of these will work. So as we look through these, one of these that would be equivalent to -5 would be number 2, because that negative sign's just going to keep coming down. And then 55 divided by 11 is 5. So that would be one possibility here. Number 3 would also be equivalent to -5. We have a negative divided by positive would be a negative. Number 5 would be another one that would work. We have a positive divided by a negative, which is negative. And then number 6 actually would be another one that would work. Remember, this negative sign on the outside can just keep coming down. And then if we have a negative divided by a negative would be a positive. So negative on the outside comes down, inside part is a +5, means that would be equivalent to -5 as well. Look at the do you understand number 3. Helen wrote the following facts to show division by 0 results in 0. Explain her error. And this is something that we haven't really talked about much in here, if at all. But I'll go ahead and mention it, is that division by 0 is undefined. So what she tried to do on the problem is saying -7 divided by 0 equals 0. We actually cannot do that. That's undefined. Dividing, think about dividing as splitting something up. So if I try and split something up into 0 piles, I can't really do that. Does that make sense? Like if I have $20 and I'm going to say, I'm going to take my $20 and divide it into 0 piles. I can't really do that. Now I can alternatively take $0 and divide that out between all of you, and you all get nothing. Sorry. But we can't do it the other way around. Does that make sense? So look at number 4. Do you know how? On 4A, we've got this negative sign that's kind of hanging out to the side here, so it can stay there. 18 divided by 3 is 6. Usually when we do these problems, I like to have the negative up in the numerator, which you're actually allowed to do. If it's just hanging out next to it, you can put it up with the numerator. But either way, that would be -6. Part B, we have a negative divided by negative, which is going to be a +5. Bad guy leaves town is good. On C, positive divided by negative is a negative, and so that would be a -4. On D, negative divided by negative is a positive, so +10. E, we have a negative divided by positive is a negative, so that would be -5. F, that negative's hanging out to the side there. 8 divided by 2 is 4, or you can put the negative up with the numerator if you want. If we look at number 5, scuba diver descends 63 feet in 18 seconds. What integer represents the change in diver's position in feet per second? Feet per second means we're going to take feet divided by seconds. Descend 63 feet means goes down, so that'd be like a -63 feet divided by 18 seconds. When you go to work that out, we know negative divided by positive is going to be a negative. And you guys could work that out. You'll end up getting -3.5. So -3.5 feet per second is the average change for the diver.